Hello everybody, today we're going to do some factoring. So it's basically some algebra that you may or may not see in your calculus courses. The first problem you would definitely not see because it's multivariable unless you are in a Calc 3 course. So the first thing we're going to do is look at the coefficients. Now the greatest common factor, that is the number that goes into both 12 and 4 evenly, if you will, is 4. So I'm going to factor out a 4. Now the next thing I need to do is find the smallest exponent of each variable. So in terms of x, my smallest exponent is 2, the smallest exponent of y is 3, and the smallest exponent for z is also 3. So now that I've factored these things out, what does that really mean I've done? I am going to divide each of my two terms by what I have factored out. So 12 divided by 4 is simply 3. X to the fifth divided by x squared. My rules of exponents say that I should just subtract. So 5 minus 2 is 3. So I've got 3 x's left. I already pulled out all 3 y's, so I'm not going to write any y's because y to the 0 is 1. 7 minus 3 is 4, so I will have z to the fourth. Now the next term, I pulled out 4, so 4 divided by 4 is 1. I'm not going to bother writing a 1. X squared divided by x squared is 1. Again, I'm not going to write 1. 5 minus 3 is 2, so I've got y squared. 3 minus 3 is 0, so I've got z to the 0, which is, whoa. And we're going crazy now. So I had y squared, and I had z cubed over z cubed, which is just 1. So this is what I would get when I factor. So that's very basic, but all of these same rules are going to apply even when we get to some uglier looking things. Now in this problem, smallest exponent is -7, so I'm simply going to factor out x to the -7th. I like to write brackets for these ones. So I'm going to subtract from all of the exponents a -7, which is just adding 7. So I get x to the 11th plus x to the 4th plus 1. X to the -7th divided by x to the -7th is 1. Something divided by itself is 1. Now I don't want to leave my answer with a negative exponent, so I'm going to write this as x to the 11th plus x to the 4th plus 1. That negative exponent means it's in the wrong spot, so it needs to move from the numerator to the denominator. And that is my final answer. If I go back through and quickly check, let's see what that would look like in our heads. 11 minus 7 is 4. 4 minus 7, -3. And then the last one is very obvious. You've got no x's. Divided by x to the 7th would be x to the -7th. So quick check, my answer is right. I could have also done that check here by distributing the x to the -7th in. So I always recommend you do some quick checks along the way. I may or may not have a good habit of doing that for you in this video. I will try to do my best. Now in the next problem, I'm going to look first at the coefficients. In the numerator, I've got a 3 and a 9. The greatest common factor of those is 3. 3 goes into both 3 and 9. Now in the bottom, I have to determine the least common multiple. That is, what number do 5 and 25 both go into? 25 certainly doesn't go into 5, but 5 does go into 25. So I'm going to factor out 25 on the bottom. Now with regards to the x plus 5, my smallest exponent is -3, so that's what I'm going to factor out. Now I write my big bracket, and now I go to dividing. So 3 over 25 divided by 3 over 25 is just 1, so my coefficient is 1 for the first term. And then I do 2 minus a -3, which is +5. So I've got x plus 5 to the 5th. I write my minus sign. 9 divided by 3 is 3. And 1/5 divided by 1/25 is simply 1/5 times 25 over 1, which is 5. So I'm going to have 3 times 5 here. And I already pulled out all the x plus 5s. So this is more or less done. If I do a quick check, 3 over 25 distributed to the first term gives me 3 over 25. 3 over 25 times 15 gives me 9 over 5. The 3 times 3 gives me the 9. And the 5 over the 25 gives me the 5 in the denominator. Now the negative 3 plus the 5 for my exponents gives me a positive 2. And then I know that x plus 5 to the negative third distributed to the second term gives me exactly what I started with. So now I simply rewrite this as x plus 5 to the fifth minus 15. And I've got to have my 3 out front. In my denominator, I've got 25 along with x plus 5 to the third. My negative exponent moves me to the bottom. And that's my final answer. It's the same thing as the first two problems, just a little bit messier looking. Now this next problem is the direct result of what you would get when you take the derivative of something using product rule. I made this problem specifically to show you what you would see from your first step of your calculus in taking the derivative using product and the combination of chain rule. So first thing I'm going to do is clean things up. I'm not going to touch my 5x squared minus 3x terms. I'm not going to touch the 4x minus 5. I'm just going to work with the other stuff to simplify. So I've got 30x minus 9. Then I'm just going to copy this other stuff down. 5x squared. So again, all I did was multiply the 3 by the 10x minus 3 term. Now I'm just going to multiply the 1/2 and the 4, which gives me 2. So I've got 2. Leave everything else unchanged. So far, I haven't done anything exciting. Now what I'm going to do is factor things out. So I look at these terms first. My smallest exponent is 2, so that's all I can factor out. Now again, I didn't have to look at any coefficients because the second term had a 2, the first one had no terms, no coefficient whatsoever. So I'm going to factor out 5x squared minus 3x quantity squared. Then I look at these terms. My smallest exponent is negative 1/2. So that's what I'm going to factor out. Then I'm going to put my beautiful brackets. Now what am I left with? Well, I still have the 30x minus 9 out front. I factored out all the 5x squared minus 3x's. And then I do 1/2 minus a negative 1/2 to get a positive 1. So my new exponent here is positive 1. Move on to the second term. I've got a 2. And I've still got a 5x squared minus 3x. Because 3 minus 2 is 1, so I still have one of those left. And I pulled out all of the 4x minus 5. If you can get to here, this is great. The rest is just cleaning things up and making it look nice. So multiplying here, I get 120x squared. I've got a minus 36 and a minus 150x. So I've got minus 186x. The negative 9 and the negative 5 give me 45. And then I've got plus 10x squared minus 6x. So that's just cleaning up the inside of the bracket. So then my final answer would be the 5x squared minus 3x. That's a bad parentheses. This quantity squared times, clean up that inside of the brackets, and I've got, looks like 130x squared minus 186 minus 6x gives me minus 192x. Then I got plus 45. And then all of this goes over the square root of 4x minus 5. That's it. Nothing crazy. Now the last one. This one's nice and beautiful. I believe this one I also made using a problem that I took the derivative of, and this would be what you end up with. So the first thing I look at is the 10 and the 6. The largest number that goes into both of those is 2. All of these things have an e to the 10x plus 3, so I'm going to factor out e to the 10x plus 3. And then the smallest exponent on sine is a 2, so I'm going to factor out a sine squared of 2x. Set up my brackets. What remains? Well, I pulled out a 2 from 10. 10 divided by 2 is 5. I still have an extra sign left because sine cubed over sine squared is simply only one sign. The next term, 6 divided by 2 is 3. And I've got that lone x that I wasn't able to factor out. Already pulled out all the e's, pulled out all the sine squareds, so I'm done. Now, you might see this if this were a multiple choice question. It might be written 2 5 sine of 2x plus 3x, and then times the e to the 10x plus 3 sine squared of 2x. All I did was kind of reorganize it just so I have my sine squared at the end and don't think that the stuff in the square brackets was being input into the sign, but that's little details. So that is factoring in a nutshell, and I hope that helps you going forward.